everyone. Thank you so much for the introduction. So today I'm super excited to be talking to you a little bit about creating animated charts with D3 and React hooks. But first, a little bit more about myself. So my name is Monica. I'm actually a dual citizen. I was born and raised in New Jersey, but moved to Poland about 1.5 years ago and have been loving life there since. That being said, as a fair-skinned, blonde-haired, blue-eyed individual who loves skiing, loves water, loves IKEA and Swedish meatballs, I feel like I fit in here pretty well as well. I work at a software company, a very cool software company in Poland called NetGuru. I love anything and everything outdoors, and I proudly consider myself to be a lifelong learner. So whether that's taking up Muay Thai boxing last year, or going canyoning in the Alps for the first time this past May, or learning to surf just this past week in San Diego. But also, I love trying new things, and that's what brought me to being a programmer, as Un mentioned. So my journey with programming actually began in college when I was a research assistant, tasked with showing some data. So the professor I was working with gave me a bunch of reports that basically had example graphics similar to what you see here. And I was bored just looking at them, not even knowing what they were meant to represent. And I just thought, there has to be a better way to show this. And there was. And luckily, I was thinking out loud when I voiced this problem, and happened to have a computer science roommate at the time who pointed me in the direction of this site. So this is D3, Data-Driven Documents, and it's basically one of, if not the most popular data visualization libraries written in JavaScript. So it's a powerful library, it's flexible, and I really consider it to be drawing with data. So since I came across this site, I've been hooked on D3, and today I'm hooked on D3 and React together, and I hope you will be by the end of this presentation as well. So today, I want to chat a little bit about React and the data visualization library, D3, but also, other than talking about just code, I want to share some secrets of the art of cooking at a fancy restaurant. So you might be a little bit confused about that last point now, but just keep it in mind as we go on, and I'll try to explain. Before we jump right into what the title of this presentation promised, though, which was creating animated charts with D3 and React hooks, I think we need to take a step back and focus on one word in particular, and that being animated. So what is animation, really, but time and change? Or to be more precise, change over time. It's about transformation, about transition, about motion. So why do we animate then? Well, it can provide value in several ways. For example, it serves as a visual cue of continuity. It's no longer two separate objects, but it's one object with continuous states. It can also serve as a reaction to a given user action. So this is in terms of communicating a cause and effect. And related to that point above, it can serve as a clue that something is happening, something is alive. So we can think of a loading component, for example. If I'm the user and I see a loading component, I expect something to be happening in the background. Hopefully it's not just an empty loading component, because that wouldn't be great. So in essence, what animation provides us when implemented correctly is really more information. So we don't just have the small blue dot, we don't just have the bigger orange dot, but we have both of them. But the beauty is that it provides more information, but there's less to process at one time. So now we just see one object transitioning states. Our eyes don't have to focus on state A, the blue dot, or state B, the orange dot, but just the object. And a little tick. There you go. So then, how does this apply to data visualization? Well, I like to think about it in terms of salt and spices. So salt and spices really represent two different approaches to applying animation in data visualizations. And just like the balance of salt and spices wins out in the long run in terms of cooking, this balance is a winner when it comes to when and how to add animation into charts as well. So what do I mean? Well, salt really enhances the underlying elements, the underlying ingredients, but it doesn't overshadow them. It doesn't overpower them. Spices, however, change the flavor profile. They bring your senses to different features, to different elements. So it's actually a combination of salt and spices that we want in our animation. We want to maintain focus, which is the salt, and redirect focus, which is the spices, in an appropriate manner. But the trick isn't just to add the salt and spices, but to add them where they are applicable. Okay, so when might that be? Well, there are certain situations that lend themselves to animation in data visualization. For example, if we have a data set A that is being replaced by a data set B. Here we'll likely have a lot of elements entering and exiting, and we want to redirect the user's attention, want to show them that something has changed. That was a spice animation. The next example is a salt animation. In this case, we have one piece of the data set A, and all it's doing is changing values. It's changing an attribute, for example. This is a salt animation because we want to maintain the user's focus on that element and show the continuity. Similarly goes for when A is a function of time. So for time series data, it's also a salt animation. And then there's something that I like to call direct redirection. So, look here, look here. So basically, this is using animation as narration or storytelling or explanation. We want to literally redirect the user's eyes to a certain location. Okay, so now we understand that animation can add value, that it can add value to visualizations, which is great, but it would also probably be helpful to know how to implement this. And this is where our two chefs come in. So have you ever heard the saying that you can't have too many cooks in the kitchen? Well, it's an American saying, but I think it makes sense globally, right? How can you have one pot, one knife, one cutting board, one set of ingredients, and expect two cooks to create one particular dish? And this is exactly the situation that we have when we're trying to integrate D3 and React. Those are our two cooks, and they both want to be in control of one kitchen, which in this case is our DOM. React is going to use the virtual DOM, whereas D3 wants to affect the regular DOM. So the issue here is about DOM management. And there are really three ways that these two cooks in the one kitchen can play out. So the first example, cook number 1 takes control. Our first cook, obviously being React. So this is the classic React that we know and love, but it's just going to be using some functions of D3 almost as a utility library for calculations. So here we have a functional React component. We start with setup, setting up the scales in this case. Then we map data to SVG elements, to rectangles, and provide them with the attributes that we need to visualize them. So in this case, that's going to be the X and Y coordinates, and a width and a height, and a fill color. And then we render those elements within an SVG container. And this is where our dimensions come in. We just set the width appropriately to the width and height to the height. And we have a bar chart. And it sort of updates when we click Get New Data. but we're missing the beauty of that animation and all of the value that it adds that we just talked about. So there's a second option, and this is when cook number 2, which in our case is D3, takes control. So here, D3 will be creating and appending and editing the elements. And this method is a bit more involved because it involves the enter-exit-update pattern that D3 uses for DOM manipulation. And that can come with a steep learning curve. But let's take a look. So here we have a class component that has component did mount, component did update, a draw function, and render. So again, we render an SVG container, which is what we need to draw our elements in. And here we provide it with a ref, because D3 will need to select something to add the other elements in. Next, we have the draw function. Within this draw function, we again define the scales based on our data. And here, D3 is now going to select the SVG container and append an empty space that it will later fill with rectangles according to the amount that our data says it needs. And in this step, append rect is doing exactly that. So we're appending the amount of rectangles that we need according to the empty spaces that bars was denoting. And here we see our animation coming in. So this is the D3 key to start an animation, and that's transition. So we include the method transition. We set a duration of 1 second, and then we include all of our end values, in this case, the x, y, width, height, and fill colors. And we can take a look, and it's much nicer. But again, that steep learning curve, and the D3 syntax can be a bit complicated. So the last piece of our draw function was to remove bars that were no longer needed. So say we had a data set that had 6 elements, our new data set has 5 elements, and we want to remove that last piece. So we're also going to remove the empty space from our DOM. So it's a lot of logic outside of our pure React understanding. And then we just call that draw function on mount and update to get what we just saw. So if the D3 option has the steep learning curve, the enter-exit update pattern that isn't pure React knowledge, might be new to some developers, and then the pure React option, using just D3 as a utility library, didn't have the animations that we needed, then let's look at option 3, which is when cook number 1 and cook number 2 share control. So here, React will be creating the elements. It'll be creating the SVG container and the elements, and D3 will be styling. So again, we have our 4 methods of this class component. We have component did mount, component did update, a draw function, and a render method. If we take a look at our render method, we're again going to return the SVG container with a reference that D3 can later select. But here, in this option, D3 will be, React will be mapping our data to rectangles. But these are rectangles without specific attributes set, because later D3 will handle filling those attributes in. So let's take a look at the draw function where D3 comes in. We define our scales again. And here, D3 is going to select the SVG container, select all rectangle elements, which React has already created, append them, attach them to data, and run our transition. So again, this is the same syntax that you saw earlier, just setting the final state of the animation that we want. The last step, again, is to just run this draw function when we mount our component and when our props update, in this case, when our data updates. And if we take a look, we get the same bar chart that moves smoothly from one state to the next. But there's a difference between working together and working together in a straightforward, predictable, organized manner where both individuals know what they should be doing. And so I like to think of it not as cook number 1 and cook number 2, but as chef and sous chef. In this case, our chef being React, and our sous chef, React's helper, being D3. So here, the chef tells the sous chef when it needs his or her help, and then gives it free rein to work its magic. So let's take a look at this. Now we have a React functional component. And we're going to be importing useRef and useEffect in this case. The first step is to use the useRef hook to set a ref on our SVG container, as we had been doing previously, but now within a functional component. And then we have our draw function, which again looks similar to what we saw. The only difference is that because we're using the useRef hook, we have to change this .svgref to selecting svgref.current. This gives us the element that we want. And then, instead of doing our component did mount and component did update, we simply use an effect and run the draw function when the data changes. So not just when all the props change, but particularly when the data changes. And we take a look, and it looks beautiful again, and the code is clean. But this pattern works for simple and complex visualizations alike. For example, with this visualization, which is what I call the non-boring keyboard. I don't know, maybe it's boring, but you can decide that one for yourself. I just like the play on words. And the inspiration for this dish, or for this visualization, was just the question of how come the keyboard is laid out the way it's laid out? Like, QWERTY seems like a very random combination of letters. And it also doesn't make sense that each language has the same keyboard if the keyboard's purpose was originally to slow down the typer when it was the typewriter. So that was the inspiration behind this visualization, and it was meant to sort of be a live exploration of that question. So here, each key on my keyboard represents one column in this chart, and I can just start typing something very unbiased in, like, wow, this presentation is awesome. And we see that a data piece is appended, and a bar is showing the user that something is happening below that. We can also change the axes as appropriate. So currently it's laid out in the QWERTY style from left to right on my keyboard, but I could change that to be alphabetical, for example. And I can also change the y-axis to see which letters in this statement are used most often. So we see a bit of animations in this case. And let's take a look at how the chef and sous chef handle a situation like this. So first, React, our chef, helps prep the pot. So we set our ref, which is going to be attached to our SVG container, and we set the dimensions of this visualization that we want. We could have gotten those from props as well, from a parent component, but here we're setting them up locally. And like I mentioned, that ref is attached to this SVG container. Next, the chef will set up the recipe, so our data. Because this input is getting just the raw input, raw keyboard input, we're cleaning it within this file, and then only using the clean data as our points data. So we're using a useState hook as well. And then the chef also will define the proportions, define how he wants to map that recipe to actual concrete elements. So here we have our point scales defined as an object, Below that, but not shown, we also have the bar scales because we have the scatter plot and the bar chart, and we have a color scale. And all of these scales come from D3. And then the chef will map that recipe to ingredients based on that mapping that he just provided. So here we're getting bars from bar data, which was actually just static data of our 26 letters. And we're getting our points from points data mapped to SVG circle elements. And now the chef will tell the sous chef exactly when he can step in. So in this case, the chef is telling the sous chef that I want you to update the scatter plot and update the bar chart whenever the points data changes. And he also provides some additional information here, such as that this transition is of type keep press. And the sous chef hears this and has the update functions ready and can step in. So in this case, I'm using a switch statement for the transition type, similar to what Redux does. And there's different cases for each user interaction or each change that we want to initiate a transition. So in this case, a key press. And we see that we have transitions to increase that bar. And then when that transition ends, we just have another transition method appended. And we run the transition to return that bar to 0 and change the color back to white. And as I mentioned, for other interactions, for other transitions, the chef can follow this same pattern. Using an effect, he can just tell the sous chef that, for example, upon an x-axis type change, when the user clicks change x-axis, I also want you to update the scatter plot and update the bar chart, this time with transition of type x-axis. And the sous chef, D3, knows what to do in that case. So here he's just going to transition over 1 second the x value. And as we see, it works. And so the change of axis here is going to be a salt animation. Because our eye can track how the columns are moving, we see that each column is a unified unit. Same thing goes for the y-axis. We see the points dropping, but we know that they're the same points. The addition of points, however, is going to be a spice animation because it's redirecting our focus to the particular place where we're adding those elements into our data set. So to recap, we talked about animation, why it adds value to data visualizations, and about our salt and spices types of animations, to add them when each dish calls for them. So in terms of salt, we want to maintain focus. So we want salt animations when a particular attribute is changing value, but the key of the object is staying the same. Spice animations when our data set is changing or when we want to redirect focus. And then we have our chef and our sous chef that will help us implement these approaches. So using the useRef and useEffect hooks, React can tell D3 exactly where and when he can step in and apply his transitions. But to close, I wanted to leave you with a few takeaways that apply to coding as well as cooking. So the first being, let the ingredients speak, don't speak for them. So there's a wrong approach and a right approach, in my opinion, to animation. The wrong approach is, what do we want to add? The right approach is, what is this visualization calling for? Same thing goes with cooking. It's not about, what do I want to add? Do I want to add salt? It's, do these ingredients call for salt or call for additional spices? Next piece, don't have too many cooks in the kitchen. We talked about this quite a bit, but a chef and a sous chef with clear delineation of responsibilities work much better. And cooking isn't baking. So what do I mean by this? It's just that this is one take on the integration of D3 and React. There have been several others proposed, but what I wanted to do today is show you a tool set that can be used in the future. So with that, I just want to say that this deck, along with examples, can be found on my website, reflectingreason.com. And I want to wish you bon appetit.